Okay, hello students. As I showed you yesterday, you're going to be rolling the ball down a ramp, off a table, into the air, and into a cup. And you're going to get one shot to do that. And so you need to think about how it is that you could make that work. So today, your job, after you watch this video, is to read the info, purpose, materials, task, and then start answering the questions. And I've structured these questions in a way so that each one builds on the previous one, each one leads to the next one. So, as you work through the questions, you should be building a deeper understanding of how it is you're going to get this ball into the cup. What kind of physics are you going to use? Which equations are you going to use? What's going on? What's the shape of the path of the projectile? So think about the stuff we've done in the past couple of days. Take a look at your notes. If you haven't been taking notes, that's a little tough, but this is why you take notes, for the things that I show you. And let's go through a few things. So first, you just have to draw the path that the bearing will take. So for that, I would click and then click Edit here, and it'll open up Drawing. Or you can go to Insert. All right, that's right there, and then click on Drawing, and you could have pasted this image in there. Anyway, if you want to draw the path it'll take, you can go to here to Line, and you can do Curve, right? Or you can do Straight, depending on what kind of line you think it's going to have. Hint, hint. Curve. All right. Anyway, when you're done, you hit Save, and it'll go right back there. If you have trouble getting that to show up, maybe refresh the document or open it in Google Docs after you open it in Schoology. And it should definitely work there in Google Docs. Let's see, next, which equation for horizontal velocity? We saw this in day 31. It should be in the notes. I gave you a link to the notes in today, day 32's assignment. Check there. Which equation for the time that takes to fall from y max? Well, we did a few of these y max problems last class. Also, you watched a video for homework last night, over the weekend. So you should have an equation for that. It's one of the four UAM equations. By the way, this is not, for number 2, not one of the UAM equations, because there's no acceleration. So think about what kind of stuff you're going to have to measure. And then also what your givens are. Givens would be things like acceleration, maybe initial velocity in the y direction, right? Things like that. Things that they're either given or implied that you already know. Any materials in addition to this list up here that you would need? There's definitely some, right? You have to take the time somehow. You probably have to video it and count the frames. So what do you need there? And then, so at this point, you've got your given info, you have a list of what you need to measure, and I want you to think about what your materials are going to look like when you're setting up things on the table to find the x velocity. So like, how would you set that up? Write me a note, say, this is, we'd put this here, we'd put that there. This is how we'd keep the ball bearing from falling off the edge of the table. How many practice runs are you going to take before you actually start collecting this x velocity data? So think about how many trials you want to take till you get it right. And then how many data collection trials are you actually going to make to collect VX data? Are you going to do 3? Are you going to do 5? Are you going to do 10? What are you going to do? And this is just a question about the ramp and the location of the ramp. Why is it important to drop the ball bearing from the exact same location on the ramp every single time? How are you going to get data for Vx? What are you going to measure? What are you going to use to make that measurement? Ruler, something else, tape measure, I don't know, laser rangefinder, I don't know. What are you going to use? Data table, there it is, made it for you. Make those things dark. Let's see, and then here, think about the motion. When is it going to be a projectile? Because it's not a projectile the whole time. So when is it going to become a projectile? And when it does, what's the initial vertical velocity component, or Vy initial? What is that? And then what equation are you going to use to solve for time? Remember, Mr. P said in the video from Friday that most of the time we're going to try and solve for time. And then you use that in both equations. So, how are you going to do this? That's it. Questions? Remind app. Have a good Monday. See you Tuesday. By the way, Tuesday is a short day.